Welcome to day 4 of DC-CAS strategies. This is Mr. Kent.
I'm Mr. Athmer.
And we're here today to talk about slopes and intercepts and finding them with a graph or a line.
Yeah.
That's true. Go Giants. Alright, so first thing we're going to talk about is what it actually means for slope-intercept form. So slope-intercept forms when we got our y is equal to mx plus b. What does that m stand for? That's what we're talking about, slope. Slope is always going to be the number that's multiplied by x. Our b here is going to be our y-intercept. Alright, how do we find m though? Well, sometimes we're given a graph. Maybe there's 2 points on the line right here. I got a point right here at 0, 2. The 0, the number that goes first is always going to be your x value, and the number that goes next is always going to be your y. I got another point down here. Here's my x, and here's my y. So this point is 2 over in the positive direction, 4 down in the negative direction. Well, if I have a line that goes through these 2 points, how can I find the slope of that line? Well, that's when we look for the change in y divided by the change in x, or the rise divided by the run. To find that, really all we need to do is see how does y change and then divide it by how does x change. So my y up here is 2. My y down here for this point is negative 4. So I might be able to do negative 4 minus 2. That's my change in y, and I could divide it by, well, I use negative 4 first here, so I gotta use my x value that corresponds to negative 4. That's gonna be my 2. 2 minus 0. So if I go ahead and do that, negative 4 minus 2, well, that's a negative 6 divided by 2, subtract 0. Well, hey, that's just 2. Negative 6 divided by 2, you got it, negative 3.
And Mr. Kent, what does that slope tell us? What is slope? I don't even know what slope is. What is it?
Well, the slope is telling you that as x changes, what happens to y. So we can think about this. As x goes from 0 to 2, y went from all the way to positive 2, all the way down to negative 4.
Aha.
So as x changes, well, how does y change?
I like that. And so now we have some other things we can talk about with these slope-intercept equations and lines and everything you see. We have intercepts, and Mr. Kent intercepted a pass just now, and what does that really mean? Well, it means where something crosses the path of something else. You intercept something. Last night, or during the Super Bowl, Blackman intercepted a pass from Tom Brady. He went in the path of it and snagged it and took it off, all right? So we have 2 types of intercepts with math, with these lines and equations. We have the x-intercept and we have the y-intercept, which we'll talk about later. The first one is the x-intercept, and there's a really easy way to do it. You don't even have to get it into slope-intercept form at all. Let's take this equation for instance, 3x plus 5y equals 15. I don't want to mess with slope-intercept. All I need to do is find the point where y equals 0, because when y equals 0, that's where x is going to cross the x-axis. So let's just plug in 0 for y. We have 3x plus 5 times 0 equals 15. All right, let's do our operations. We're left with 3x. 5 times 0 is 0, so I can just leave that blank, and equals 15. And our last step is to undo the multiplication, so we divide by 3. Divide by 3 on both sides, and x-intercept is going to be x equals 5. So our point of the x-intercept is 5, 0. That is our x-intercept. But then you ask yourself, wait a minute, but I like working with slope-intercept form better. I think it's easier, and that way I can find the slope as well. Let's go back to Mr. Kent's whiteboard and look at slope-intercept.
Again, we have y is all alone here, and that's equal to mx plus b. So in the equation that we were just looking at, y and x were on the same side of the equal sign, okay? So we got to figure out a way to get y alone and then all of our numbers, all of our x's on the other side. So let's go on back over to Mr. Athmer's board and let's solve.
All right, so let's do that. Let's put it into slope-intercept form. We want to get y by itself right here. We got to isolate the y. So my first instinct is to subtract 3x because we want to get it off of the y side. So let's rewrite everything. 3x minus 3x is nothing. So we're left with 5y equals 15 minus 3x. So here we are. Y is not by itself yet. We got to get rid of that 5. So the opposite of multiplication is division. So let's divide by 5. All terms by 5. The 5's cancel. Now I see y by itself. 15 divided by 5 is 3 minus 3x over 5. And you ask yourself, Mr. Athman, that still doesn't look like y equals mx plus b. You know what? Let's make it look that way. Let's put the constant on the end. That's very easy to do. So there is our slope-intercept form. And now what's the slope? Well, it's the one that's multiplied by x, so it's negative 3/5. So that's what Mr. Kent talked about.
And Mr. Athman, what's our y-intercept?
And our y-intercept is b, which is y equals mx plus b. It's the b in the equation, so it's 3. It's that constant. It never changes. It'll always cross the y-intercept. That line will always cross the y-intercept, or the y-axis at 3. And last but not least is a similar situation with the y-intercept. What happens if you don't have it in slope-intercept form? Well, you could change it to slope-intercept form if you want, like we did here, but you don't have to. You can plug 0 in for x, because whenever x is 0, that's where the line's going to cross the y-axis. So let's just plug in 0 for x. 3 times 0 plus 5y equals 15. 3 times 0 is 0. 5y equals 15. How do I get y by itself? Let's undo this operation of multiplication. And so we need to divide. Divide. Y equals 3 as well. So the point where the line crosses the y-axis is 0, 3. There's our y-intercept. So again, you don't have to always get it in slope-intercept form. If you feel more comfortable that way, please do that.
You guys have a couple problems on your practice packets? Get after it. Go blue.
Give me a pass, Mr. Kent.
Oh. Go Griffins! Oh.